Hello guys, welcome to Ramta Solutions and welcome to your grade 12 mathematics. We are looking at grade 12 financial maths, of course. So in this past paper series, we're looking at a paper that was written by grade 12s. So this is your final grade 12 paper, national paper that was written in November 2023. Okay. So without any waste of time, let me open the paper so we dig in. Okay, here is it. I'm going to pin it. Okay, so it's pinned. Is it? Okay, so before I proceed, guys, if you are using a mobile device, please rotate your screen so that you have maximum viewing. Okay, all right. So let's go. Now, instructions that I want to use while we're doing this video is this. Instruction number 4, clearly show all calculations, diagrams, graphs, etc. that you have used in determining your answers. And then instruction number 7, if necessary, round off answers to 2 decimal places unless stated otherwise. And I want to add on this. Okay, I want to add on this. In the middle of your calculations, do not round off your answers, only around the final answer. Round your final answer to 2, or round off your final answer to 2 decimal places. Okay, this is important. All right, so these are all that I will be looking at. Okay, proceeding. So now we're here. So we have, let's see, now let's see, your paper, your question data is in maybe question 6 or even 7, but I think this is question 6. All right, question 6. I repeat, if you're using a mobile device, please rotate your screen so you have better viewing. Okay, let's go. Question 6. In the Northwest, they say Botsoya Borataro. So question 6, they say Patrick deposited an amount of 18,500 into an account earning R% interest per annum, compounded monthly. After 6 months, his balance is 19,319 rands and 48 cents. 6.1.1, it says calculate the value of R. Okay, it says calculate the value of R. So this will be A equals P into 1 plus I, okay, 1 plus I to the N. Now, what do we know? We know that after 6 months, his balance was 19,319 rands and 48 cents. He deposited, Patrick is a male, obviously, he deposited 18,500, right? Now, the R is basically the interest rate. So what was it? It was R%, so it's R over compounded monthly, it'll be R over 12. And here you will have, because it's after 6 months, it'll simply be 6. Okay? It'll simply be 6 because it's after 6 months. Okay? Perfect. Now, let's see. Taking out our calculators, 19,319,48 over 18,500 is, what do we have? Okay, we can't get it as a fraction. It's okay. So let's just say, you know what? Let's just say 6th root of 19,319,48 over 18,500. Okay, over 18,500. Okay, remember 6th root of it. 6th root of this guy. 1 plus R over 12. I think it's better that way. Right? So let's see. 6th root of 19,319,48. Okay, over 18,500. What are we getting? Okay, we are getting, let me see. I want to confirm 19,500 319.48, that's correct, over 18,500. Okay. Right, perfect. What are we getting? We are getting 1,007250019. Remember, you're supposed to, like I said, you're not supposed to round off your answers in the middle of calculations. What you can do, if you want to round off, because nobody has time to be writing such a long thing, you can perhaps use 4 or 5 decimal places. It'll be okay with you. Okay? So it is equal to 1 plus this guy. So now this becomes 0.007250019 equals R over 2, right? Because 1,00725 blah blah minus 1 will be this. Now this we multiply it with 12. Okay, this we multiply it with 12. So what does it become? It becomes 0.087000. It's fine, I'm going to leave it there, equals R. Therefore, we can conclude when we multiply by 100, we will say our R is basically 8.70%. Okay, our R is 8.70%. Okay, so this is the value of, okay guys, perfect. Moving on, 6.1.2, calculate the effective interest rate. So with the effective interest rate, we use the formula 1 plus I effective equals, open bracket, 1 plus I nominal over, let me call it F, close to the power F. Remember, nominal interest is an interest that is quoted more than once a year. Okay. So now, what do we do? So what do we do now? We proceed and say 1 plus IEFF equals 1 plus nominal interest. So the one that we got earlier, it was what was it? It was 8.70%, which when you divide it by 100, it'll be 0.087. All right? 0.087 over it was monthly over 12, close to the power 12. Okay, so let's simplify this. 1 plus, open bracket, 1 plus 0.087 over 12, close to the power 12. What do we get? We get 1 plus I EFF. I effective is equal to 1,090554346. Now this means I effective or IEFF is equal to, of course, minus 1, right? It is equal to minus 1. So this then becomes 0.090554346. We can basically say this is, if you multiply it by 100, what do we say? We can say this is 9.06% per annum. This is your effective interest rate. Okay, this is your effective interest rate. Remember, key thing is to use this formula. By the way, guys, this formula is not given in your formula sheet. Okay, let me confirm for you. Can you guys see that? Under finance, you get it? It is not given in your formula sheet. So it's one formula that you should know. Okay, perfect. All right, 6.2, let's see. Kuda bought a laptop for 10,000 rands on 31 January 2019. He will replace it with a new one in 5 years' time on 31 January 2024. Okay, in 2 years, 5 years' time, sorry, in 5 years' time. Right, so the value of the old laptop depreciates annually at a rate of 20% per annum, according to the straight line method. I want you guys to highlight this straight line method. I know you are used to a reducing balance method. This is a straight line method. So, now, after how many years will the laptop have a value of 0 rands? So 6.2.1. we will say A is equal to P into 1 minus I times N. Okay, because this is your straight line depreciation. Okay, or what you call your simple depreciation. So after 5 years, wow, it means if I were to go to game after 5 years, this laptop is free. Yeah, that would be nice. Okay, so now he bought it on 31 January. He bought it at 10,000 rand. So what are we looking for? We're looking for N. Okay, we're looking for. Now, what was the rate at which it was depreciating? 20% per annum. So 20 divided by 100 is 0.2. Isn't it? Cool. So now what do we have? What we have here is we can say, aha, this is 0 into 1 minus 0.2n. All right? So you can say 0.2n equals 1. Now what is n? N will be 5. All right? N will be 5. So how long will it take for this laptop to have a value of 0 rands? It will take it 5 years. Okay. Therefore, it will take 5 years. Okay, it will take 5 years. Okay, it will take 5 years. Now, 6.2.2, Kuda will buy a laptop that costs 20,000 rands. In order to cover the cost of the price, he made his first monthly deposit into a savings account on 28 February 2019. He will make his 60th payment or his 60th monthly deposit on 31 January 2019. The savings account pays interest at 8.7% per annum compounded monthly. Calculate Kuda's monthly deposit into this account. All right, cool. So this, I suspect, or I don't suspect, it is future value annuity. Okay, it is future value annuity. Remember, the account, this was an account that lasted for what? 60 months, right? It lasted for 60 months. So this is the timeline for it. He starts making, remember, he bought his laptop on 31 January 2019, and then he starts paying towards the savings of a new laptop. When? On 28 February 2019, meaning at the end of the term. So this is X, 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 X. And of course, we know what the interest is. So this equation, okay, so this equation this situation is your normal future value annuity. Okay, this means we're going to use that formula the way it is. So that formula that you know, it says F equals X into, open bracket, 1 plus I close to the power N minus 1 all over I. Okay, now what is Kuda's future value, or the amount that he wants to save for? It's 20,000 rands. We don't know how much he's depositing per month. That's what we're calculating. The interest is it's 8.7%. So we'll write it as 0.087 over monthly. So it's over 12. And how many installments does he make? He makes 60 installments. Okay. He makes 60 installments. So over 0.087 over 12. I'm going to leave the left-hand side as it is. The right-hand side, guys, there are those who prefer to just calculate to get your answers once cut. It's okay, right? There are those that want to get your answers once cut, once off. That's okay. But for those that do not like doing that, let's do it in this way. The right-hand side now becomes fraction, open bracket, 1 plus 0.087 over 12, close the bracket, to the power 60 minus 1 in your denominator, 0.087 over 12. So what is this? So here what you have 74,833,16663x. Now what you do, remember guys, most of you, I realized we are using KCL. So you will just say, currently, this is the answer that's displaying in your calculator. Okay, so just press, do not press anything, just press 20,000 divided by answer. Your answer is, what is this? Your answer is, what do you term it? is what you term, remind me please. Oh, let me see. Your answer is what you term, sorry, what is your answer? Your answer is what is called ANS there. Okay, is what is called ANS there. So you say 20,000 divided by ANS, what do you get? Your answer now becomes, my mistake, your answer now becomes 267.26. So in other words, Kuda has to invest per month 267 rands and 26 cents for 5 years towards a new laptop. Okay, every month, this is what he will be investing or what he will be depositing into their account. Okay, all right, thank you. Remember, guys, use the smart tabs that are on your calculator to save time. Okay, perfect. Now 6.3, I have to go to the next page. Yeah, I have to go to the next page. So let's see. So 6.3 says Tino wins a jackpot of 1,600,000 rands. He invests all of his winnings into a fund that earns interest of 11.2% per annum compounded monthly. He withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000? Highlight this. How many withdrawals of 20,000 will Tino be able to make from this fund? So this is your normal present value annuity. Okay, this is your normal present value annuity. I don't know how many years it takes. So let's say this is Tino investing and this is him at the end of the term when he wants to get his payment. All right, when he wants to get his payment. So now, this question, I say to you, please highlight how many withdrawals of 20,000 will he be able to make from this fund. Okay, so let's proceed. So the formula that we're going to use is the normal present value annuity formula. Okay, 1 plus I to the power negative n all over I. So what is this money that Tino deposited? He invested 1,600,000. All right, and how much is he withdrawing per month? 20,000 rands. And the interest that the bank offers is, or is it 11.2%, which is 0.112 over 12 to the power. We don't know how many years the investment is for. Okay, that's what we are looking for. Over 0.0, oh my, 0.11. So it's 0.112 over 12. Of course, to simplify this, I will write it as 1,600,000 multiplied by 0.112 all over 12, not all over 12, then these all over 20,000. Okay, these all over 20,000. Okay, these over 20,000 equals 1 minus 1 plus 0.112 over 12 to the power negative n. So let's see what we're getting. On my calculator, we'll use 1.6 times 10 to the 6 multiplied by 0.112 over 12 over 2 times 10 to the 4. Okay, 2 times 10 to the 4. All right, 2 times 10 to the 4. Let me wait for you guys. Okay, you guys got it. You got 56 over 75, right? Oh, yeah. So this is it. 56 over 74 is equal to 1 minus, let me go back, 1 plus 0.112 over 12. It simplifies to, I'm not going to round it off, I'm just going to write it as it is, 757 over 750. Okay, over 750 to the power negative n. So 757 over 750 to the power negative n is equal to 1 minus 56 over 74. What do we get? What do we get? Yeah, it's 1 minus. What do we get? I'm not sure. 1 minus 56 over 75. My mistake. 56 over 75. It wasn't 74. It was 75, right? It was 75. So what do we get? We get 19 over 75, right? We get 19 over 75. Then logarithms. This is equal to alright, so this is log 79 over, oh, why am I saying log 79? This is log 19 over 75 base 757 over 5, isn't it? 757 over 5, my mistake. I don't know why I keep repeating this mistake. So this is log 19 over 75 base 757 over 750. So now you can press this on your calculator and tell us what you're getting. Let's see now. Fine. Okay. What are you guys getting? I get negative n equals negative 147.7978688, meaning that this is minus, not minus. Dividing by negative throughout, this is 147.80. Therefore, I want you guys to pay attention. You see, these decimals are saying that basically Tino will have about 148. He will have about 148 withdrawals. However, the 148th withdrawal is going to be less than 20,000. Now, this question is asking how many withdrawals of 20,000 will Tino be able to make. He can only make full 147 withdrawals of 20,000. So, therefore, he will make 147 withdrawals of what? Withdrawals of 20,000. Okay, withdrawals of 20,000. Okay, I repeat, guys. This says that in general, he's going to make 148 withdrawals. But for 20,000, he can only make 147 payments. That means the 148th payment will be less than 20,000. Okay, but this question does not want you to calculate that 148th payment. So it's okay. All right. So this is it, guys. This is how you attempt finance. Okay, this is how you attempt finance. And I know for this question, most of the students who wrote this, or even you guys who are doing these past papers, the fact that 6.2.1 was saying you must use the straight line method. You guys are not used to straight line. And this is why this is an exam. An exam is to test you on the knowledge of everything you have done from grade 10, 11, and of course, grade 12. Okay, this is the beauty of it. And I appreciate that they only made it to be 2 marks. But I trust you guys. You aced this. And you who are currently in grade 12, I know you will also ace this if they ask you this question in this way. All right? So, with that being said, ours ends here, and I want to say to you, if you enjoyed this video, please subscribe, like, and share with your classmates and anyone who might be in need of this. And of course, if you want to get in touch with us, you can visit our website, ramtasolutions.co.za. At the top on our website, you will see all these tabs. Okay, you can click on them to either email us or these 3 to subscribe or to follow us on your favorite social media platforms. And of course, because you are on YouTube, you can follow us, you can subscribe as well. Okay, so this is it, guys. I wish you all the best. So, bye.